Well, hello. I'm Eric Salna, Associate Director with the Extreme Events Institute at Florida International University here in Miami. And we're here live at the National Hurricane Center, which is right here on our FIU campus. We're going to get a very special tour today and learn all about how this agency and how this facility works. And it's very important because we all know today's the 31st, but tomorrow is June 1st, the beginning of our next hurricane season. So with that in mind, I'm going to bring in a very, very special friend and guest here with the National Hurricane Center, Mr. Dan Brown. Thank you for joining us.
Thanks, Eric. Thanks for having me today.
Yeah, so first off, tell everyone what's your personal role here at the National Hurricane Center?
Sure, I'm what we call the warning coordination meteorologist here at the National Hurricane Center, and also serve as one of our senior hurricane specialists. So that means during the hurricane season, which, yes, starts tomorrow, I'll be doing the forecast for tropical storms and hurricanes across the Atlantic and Eastern Pacific. I'll also be looking for areas that might develop into tropical storms and hurricanes. I roll during the off season, which everybody always asks me about because everybody's always curious to know what we do for the 5.5 months that we're not in hurricane season, is to make sure the public and folks like you are well aware of the threats from hurricanes, and we train emergency managers and media and other partners that can help get that message out to folks like you at home.
Absolutely, that's great. And in general, describe just a little bit the overall, what is the the purpose and the role of the National Hurricane Center?
Sure, the National Hurricane Center has both international and U.S. responsibility to put out forecasts for tropical storms and hurricanes. We issue a 5-day forecast for anything that develops in the Atlantic or even the Eastern Pacific Ocean. And with that, we put up watches and warnings to help warn the public when wind or storm surge hazards might affect them. And we have to work closely with all these countries in the Caribbean to be able to do that. And based on that, we're called what's called a regional specialized meteorological center by the World Meteorological Organization, again, giving us those additional responsibilities to warn not only folks in the U.S., but across the Caribbean.
And for any students out there that are thinking of career opportunities and thinking about meteorology or NOAA or the National Hurricane Center, what would you say?
If you like science and math, consider being a meteorologist. I actually got very interested in meteorology when I was about middle school, and it's really a dream that I'm working here. I followed that dream, went to school, and got my meteorology degree. Luckily got hired here at the Hurricane Center right out of college, and I've had I call it a wild ride ever since. I really enjoy what I'm doing. Most folks that are here are very, very passionate about what they do. Again, it's something that's really different every day. I get to look at neat satellite pictures, seeing the weather across the Atlantic and Eastern Pacific and the U.S. And then not only am I doing something that I enjoy, but it's also helping a lot of other people.
And we really appreciate the great partnership that you have with us, FIU and the Extreme Events Institute, a partnership with us and the FIU community and meteorology students. That's a very great partnership.
Oh, absolutely. We can't do it ourselves. We have to have a lot of partners to be able to get that message out. And so we work with folks like yourself at FIU to make sure people are prepared each and every hurricane season. We work with a lot of media folks. Today was what we call Media Day at the Hurricane Center because tomorrow is June 1st, the start of the season. So we had lots of media here, again, helping to get the message of preparedness out, helping folks to think about the upcoming hurricane season. And then we also have emergency managers that are helping communities prepare to make sure we're all ready this hurricane season.
And we are all honored for sure at this past National Hurricane Conference. A great research partnership with the Storm Surge Unit here at NHC and the Storm Surge research team at the Extreme Events Institute at FIU, receiving an award for storm surge work in Haiti and Dominican Republic.
Yeah, and so many people think of wind when we think of hurricanes. In fact, I bet most of you think more about the wind than the water. But unfortunately, it's really the water that's killing most people when hurricanes make landfall in the United States. In fact, it's about 9 out of 10 people die in the U.S. in hurricanes from water, not wind. And so it's something that we here at the Hurricane Center have been aware of. They're trying to warn now folks more about the storm surge threat. And that's when the ocean water gets pushed onshore, flooding areas that are normally dry. And so starting in 2017, we started issuing storm surge watches and warnings. If you hear that watch and warning and you're in one of these areas that's at risk for getting flooding from storm surge. And at that point, you got to listen to these emergency managers, listen to those evacuation notices, and if you're told to leave, please do so. Talk to your parents about that. Find out if you live in one of those evacuation zones today before the hurricane season starts.
And today was a big day here at the National Hurricane Center with media, all because of tomorrow, June 1st, and the forecast and the beginning of the season.
Yeah, so NOAA puts out a seasonal forecast, and that's calling for the greatest chance to be a near normal season. But I always like to tell people, we can't really think too much about those numbers. It only takes one hurricane to hit our area for it to be a bad year. You go back to 1992. That was Hurricane Andrew. It was a Category 5 hurricane that struck here near Miami. And that year we only had 7 named storms, only 4 hurricanes, only 1 major hurricane. But unfortunately, that major hurricane was the one that hit us, making it a very bad year here in Miami-Dade County. So the message is we got to be ready each and every hurricane season.
Absolutely. Well, let's go ahead and, if we can, take a tour of the National Hurricane Center and see how all this works.
Sure. I'm so glad everybody could join us today. And right now we're in the area where all the media gathers when there's a storm. And our media is here again we need the media to help get the message out. If I make a forecast and nobody hears it, they're not going to be able to take action on that. So we really need the media to help be our partner to get that information out. So we have a couple desks here where we actually can do interviews in real time when storms are threatening the United States or other areas. And so that's kind of the first part of the tour. And then we move a little bit beyond that is where we actually move into more of the operations of the National Hurricane Center. And we actually have some forecasters that are here on shift today. And we're actually starting to look at an area of cloudiness and weather that's across the southern Gulf of Mexico. And some of our models suggest that we could see it try to organize a little bit over this weekend, perhaps try to become a tropical system before it reaches the coast of Mexico early next week. So we're already watching our first disturbance of the year. And what happens here is we have forecasters that work essentially various shifts during the hurricane season. And we're monitoring all these cloud clusters and disturbances across the Atlantic. And then we look at what we call computer models. These are simulations of how the atmosphere is going to evolve over the next several days to help us make those forecasts. So first we have to analyze where the storm is located, how big that storm is, and then how strong the storm is. Put that information into our computer models. They run those forecasts. And then we make a forecast based on those. And the most important thing we do is then try to communicate the risk of that storm. And we do that by talking about, again, where that storm surge that I talked about earlier could be, where the strongest winds might be, and then also where that heavy rainfall could occur, and also where there might be tornadoes. So it becomes a real collaborative effort between folks here at the Hurricane Center who's looking at the bigger picture, along with our local National Weather Service offices around the country. We have 122 of those, and several of those are along the coast, and then they help to communicate that information down to the local level so that everyone can try to stay safe during the hurricane season.
Absolutely.
I don't know if you have any questions for me, Eric.
Well, in this particular forecast area that we're looking at here now, maybe a little information what they're doing now and how that area is used during the forecast process.
Sure. So right now, Dr. Lixie Avila is the forecaster on duty today, and he's already looking at again that area of weather in the southern Gulf of Mexico and across parts that's just south of Mexico. And then he's looking here at some computer model simulations of, again, how the weather might evolve over the next couple of days. And you can kind of see this little spin that shows up, which is showing that maybe we'll start to see a low-pressure area try to form and try to organize before it reaches the coast of Mexico later this weekend. And then he is starting to think about how he might want to communicate that information to the public. Do we need to issue what we call a tropical weather outlook, talking about the system's chance for development over the next several days?
Mm-hmm.
And you can see, again, a lot of computers, a lot of computer technology, and then we also have satellites that we can look at. And we get images from those satellites every few minutes to be able to look at how the clouds are moving and, again, how systems might become organized. And you can kind of see Florida, where we're at, right up here in the top part of the screen.
Mm-hmm. So, and again, for the students and career opportunities, lots of computers, but there's a lot of math and physics involved, isn't there?
There absolutely is. When you get a meteorology degree, it's typical of most sciences. It requires a lot of math, physics, and it's also good to have a computer background because, again, we have so many computers. Dave Zielinski is one of our folks that has done a lot of development on some of our computer technology and also some of the products that we issue here that the public actually sees. Some of those being a graphic showing when the winds and when those hazards might start to arrive on land that we issue now. And again, there's one for storm surge that shows how high the water could reach and how far inland it might penetrate. And again, these are communication tools to help folks know what their risk is and help make better decisions.
Mm-hmm. And so the whole process too, once there is a potential system, advisories, and potentially a cone forecast and all the other products.
That's correct. That's correct. One thing that's behind you too is we actually, again, I mentioned that we had to talk to all these different forecast offices around the country. Well, here's a video of a monitoring system where we actually can start to see each other. So when there's something threatening the United States, we'll actually call up all those offices and then they can see us, we can see them, and we can talk about where those hazards might occur and then also whether or not we need to issue any tropical storm or hurricane watches and warnings. Mm-hmm. So again, it's a really neat to be able to talk to them in real time and for us to talk about that information.
Mm-hmm. So Dave, you want to mention just a little bit about your role and your part of the process?
So I, like Dan, am a hurricane specialist here at the National Hurricane Center. My background is maybe a little different, though. I came from the technology side of the house originally. So like Dan was saying, I've done a lot of work with our computer systems and our product development. And I think, especially for students thinking about what they want to pursue, if you have any interest in meteorology or a lot of other sciences for that matter, computer programming is a great way to get into it. You can see how many computers are here around Lixion. And someone had to do the coding to get all of this data ready to go. And you can't just ask anyone off the street to do that if they don't understand it. So, computers and technology is becoming a really big focus. Another way to think of it is, I like to ask people, how do you think we actually predict the weather? Do you think we cover our eyes and throw darts, or maybe magic 8-ball? And the answer, of course, is math, which isn't that exciting of an answer. But it's really hard math, and because of that, we have to use computers to actually do the hard problems, to do all the problem solving. And people have to do the coding for those. Mm-hmm. So as a result, the technology side is really important now.
Mm-hmm. And the National Hurricane Center has made improvements when it comes to forecasting track. Certainly wind is still a challenge, intensity, mm-hmm. but improvements over the years with the computer modeling and the science and the math and physics have led to improvements.
Absolutely. Over the past several years, I think if you look back over the last 25 years or so, our forecasts at day 2 or at day 5 are now as accurate as they were at day 2, just 25 years ago when it comes to track. And we're finally starting to get some improvements in intensity as well. Mm-hmm. Certainly we're not all the way there yet, but for the first time in several decades, we're actually seeing incremental improvements, and that can really be attributed to improved modeling.
Mm-hmm. And why do you do it? Why do you like doing this?
Well, the funny thing is, a lot of people here, they have a story about why they got into weather. Some big hurricane or something. I grew up in Detroit. We don't have hurricanes in Michigan. We had a tropical depression last year in Alberto, but typically they don't make it that far north. But when I was 4 years old, we had a storm called a derecho. Strong winds, but they're straight line winds instead of rotating around some larger center. And it knocked a tree on our house. And for whatever reason, most people think that was pretty scary. I thought it was great, and I wanted to know why that could happen, why the weather could do that, and wanted to study weather ever since. So that's what got me into it. And the more I learned about how weather affects everyone and how you can do a lot of good, just, you can help people by getting them better prepared for especially events like hurricanes, the more interested I got.
Yeah, fantastic. Well, thank you very much for your time. Really do appreciate it.
My pleasure.
Eric, I was going to show that even with all this computer technology, that we still at the Hurricane Center, for most storms affecting the United States, we actually keep a paper track map. So just like you can do at home when you track the storms, we're doing that here at the National Hurricane Center. This is the map from Hurricane Michael last year that made landfall in the Florida Panhandle as a Category 5 hurricane. And you can see that what we get here are various estimates of where the storm is located. Some of these that you see in blue with the squares are satellite from satellite estimates. Some of the red triangles are from our aircraft that we fly into storms. And they all help us to know where that storm is located at various times. And then if you look really closely, you can see some of these eraser marks, which are some of the forecasts that we made. And we actually plot those forecasts, and we'll erase it and then plot the latest forecast. And we can see, again, how the forecasts are panning out also by looking at this as well. So there's still some hand analysis, and the human is definitely part of the forecast process. It's not a bunch of computers making a forecast. It really is someone sitting here doing that.
Because ultimately, as what's been said, the computers are tools, the models are tools, but ultimately it's someone like yourself or Dave or a member of the forecast team, a person, a human, that has to then make the decisions and then make the ultimate forecast.
Yeah, absolutely. Now, I did tell you, if you're ready to move on into the other area, I was going to say, now I did mention that we fly aircraft to storms. I was going to take folks back into that area, see if we can talk to Warren Madden. He's the person that we actually coordinate these aircraft with. And that's a really great tool for us as forecasters, because if I don't have the aircraft, I have to estimate how strong the winds are from satellite. But once we fly a plane into it, they can really provide that data back to the forecasters. And it's really great information.
And on the way,
I will show you. We do keep a map here showing our area of responsibility. We do cover a huge area. In fact, I always find it interesting that one day I could be talking to folks in Mexico about a storm threatening Mexico. The next day I could be talking to folks in Hispaniola, Dominican Republic. And then I could talk to folks in Bermuda, and even talk to folks out in the Cape Verde Islands about storms that might be threatening their area. So it's just this huge area that we cover. Again, it goes from Africa all the way across the Atlantic, covering the islands. And then in the East Pacific, we cover forecaster storms that form off the coast of Mexico and typically move away from the coast. And here at this line called 140 degrees west longitude is where we divide and we pass it off to a forecast unit out in Hawaii, and they're responsible for storms that affect the Hawaiian Islands. So again, they're part of the National Weather Service as well. We work closely with them, but it just, again, shows how big this area that we have to cover and are responsible for.
and tomorrow, June 1st, is the start of our local hurricane season, but hey, they already got started in the Eastern Pacific.
That's true. East Pacific season starts on May 15th. So typically about every other May, we have a storm in the Pacific. We didn't have one this year, but we already have had one named storm out in the Atlantic this year, and that was a subtropical storm, Andrea, that formed. It was a very short-lived storm, but it did form. And the reason we issue advisories on those type systems is because, don't forget, there are people that are out on the water. There are ships at sea that need this critical information, because when the winds and seas are high over the ocean, it's not a very pleasant ride. We want to keep those folks safe as well. So we also have a big marine component. We actually have a branch here at the Hurricane Center that provides marine forecasts across these entire Atlantic south of about here, and then also the Eastern Pacific. Those folks are here year-round because they're doing forecasts every day of the year. Again, keeping those boaters safe and cruise ships safe from hazardous weather.
And that is critical, all shipping operations and so on during the tropical season. Very important.
Yes, it absolutely is. I would not want to be on a ship that gets anywhere near a hurricane, and I don't think you all would either. So we hope those cruise lines and others, and we do get a chance to meet and talk with those folks as well during our off season, hear what their needs are, and try to maybe change how we communicate these threats with them.
And this is the list of names we hope never to use.
This is our name list for this year, and you'll see we'll start with Andrea, which has already been used. Our next name storm will be Barry. We work our way down the list. The names actually rotate in a list every 6 years. So these names that are used here in 2019 will begin to be used in 2025, unless one is very destructive or devastating causing a lot of fatalities. If that happens, then the country that gets affected can ask this organization that includes representatives from all across the Caribbean to retire that name. Last year retired both Florence and Michael. They were both very devastating storms in the United States. And so once the names are then retired, the committee votes. I've been to the meeting. It's kind of neat to see everybody raise their hand and vote for the name to be retired. And then we place names in nomination, and they'll replace names. So last year with Michael being a Cat 5 that went into Florida, that name was retired and replaced with Milton. So in 2024, we could have a Hurricane Milton in the Atlantic.
There you go. So now we're going to head over to
let's head over this way. Let's see if we can catch Warren.
Again, everybody, we're here live at the NOAA National Hurricane Center facility on the campus of Florida International University, talking with forecaster Dan Brown.
Sure, and Warren sounds like he's busy coordinating some things at the moment, so he'll be here to join us just a second. But this is the room where we actually can talk to 3 meteorologists that work here that help us coordinate our aircraft needs. And so when I say aircraft, we actually have a fleet of 13 aircraft that can fly in and around hurricanes. And you can see various models of these aircrafts up here. We have, it's hard to kind of see way back here, but we have 10 of these C-130 aircraft that are Air Force aircraft. And these aircraft fly right into the eye of the storm. I don't know if anybody out there would like to fly into the eye of the storm. I'm not sure I would want to, because it's a very, very bumpy ride. When we talk to Warren, he's done it, so he'll tell you what it's like. And then we have 2 NOAA P-3 aircraft that can also fly right into storms. These aircraft also have a capability to do a lot of research. In fact, one of them is out in the Midwest in the Great Plains right now doing tornado research, flying around some of those severe weather, severe storms we've heard about in the last week or so. And then we have 1 G4 Gulfstream aircraft that flies up and around the storms. This aircraft, and Warren's going to tell you about what it does, but it drops instruments around those hurricanes for information for our computer models. And when we do that, we actually improve those models' forecasts, because now they have more information to know exactly what that storm looks like, the structure of the storm, and the environment around the storm, helping to improve those computer model forecasts, which helps me out a lot by making my job maybe slightly easier, maybe more consistent models and even better model forecasts. And that's one reason we've seen those improvements in our track forecast. But here's Warren Madden. He's one of the meteorologists. He actually flew in the Air Force aircraft into the hurricanes, and he also now works here at the Hurricane Center, helping to coordinate all our aircraft needs. And then as that data comes in off the aircraft, he runs it out to me as a forecaster. I'm going to turn it over to Warren and let him tell you everything that he does.
Well, hi, everybody. My name's Warren Madden. I'm an employee of the Air Force. I'm also a retired lieutenant colonel. And as Dan mentioned, yeah, I used to fly into hurricanes. I flew into hurricanes for over 10 years. It's kind of like riding a roller coaster in the same time being in a car wash. It can be just that bumpy and dropping out from under you and rising back up, and then the rain is just pounding against the aircraft. But we do it because we need to get that information. There's some information you can only get by getting inside the storm, and it's that very critical information, how strong the storm is in terms of the wind speeds and how low the central pressure is. That's the kind of information that we have to get over to Dan and the rest of the forecasters immediately, so they can use that as part of their forecast process, because it might make a difference, say, between the storm being a Category 3 storm or a Category 4 storm. And if the storm certainly is stronger, then everyone needs to know that so they can do what they need to do to protect themselves, their families, and their property. So we do have a variety of aircraft, as Dan was mentioning. Our main aircraft are those WC-130s. That's the kind that I flew in. And then we have also our science-related aircraft. The P-3 Orions are going in to see about how these storms work, to help improve forecasting models, to test out new instruments. And then the G4, the high-flying aircraft, just like a cork floats in a river, well, so does a hurricane float in the rivers of air that are always flowing around the earth. And so we need to know how those rivers are flowing to help figure out where the storm's going to go. So all 3 of the types of planes have instruments on them for measuring weather information, but we also need to know what's going on from the planes all the way down to the surface. So for that, we use these. This is called a drop sonde. It's called a drop sonde because we drop it out of the aircraft. Actually, we fire it out the bottom of the aircraft. We have kind of like a dart gun, a big old dart gun to fire it out. And a little parachute pops out and it floats down to the surface, and it's got a variety of weather instruments in it. This little tip in here, that's a thermometer and a hygrometer, which measures the humidity, the amount of water vapor in the air. Inside here, there's a barometer, which measures pressure, because a key component of how strong a storm is what's the pressure of it at the very center. If you've ever been to kind of maybe one of the science museums and seen those big funnels where you can put coins in and they spin around and around and around, that's kind of like the center of a hurricane. And those coins going around and around, that's the wind as it spins up, as it gets closer to that pressure hole down at the bottom. And then the last thing this thing has in it is a GPS receiver, just like your cell phones or the kind you have in cars. And so as it's falling down, it's yelling out to the plane, I'm here, I'm here, I'm here, several times a second. And then the computer on the plane can take all those positions and figure out how the wind is moving the drop sond along, so we can know how strong the winds are. So those planes, we can have several planes out there flying at any one time, and they are all sending their information back to a satellite antenna here on the roof of the Hurricane Center, and they all flow to the computers you see around me in the office. And so myself and the other two people who work here, we're working and looking at those computers and talking with the planes via effectively text messages. And then we get that information, we look at it, and then we bring it over to the forecasters and we go get it out to the rest of the world. So when you see the meteorologist on television talking about, here's Hurricane Irma at this latitude and longitude moving in this direction, that's information that came from the planes and came in through this office. So it's a really important job, and the forecasters really like getting our information because it does help give them that little extra information that can make all the difference in their forecasts. We've been doing this now since World War II, and we do everything we can to be safe. There's always going to be a little bit of risk, but we take the risk. The men and women of both the Air Force and the NOAA squadrons, they go out there and put themselves out there so that you and your parents and everyone else can have the best possible information so they can take action to protect themselves, their property, and their children's lives, their relatives, and their pets. Because the last thing we want to have happen is for somebody to be sitting in a house maybe a couple of blocks off the beach, and there's wind whipping around, tree branches flying everywhere, pieces, garbage cans and whatever, and then now here comes this big wall of water, the storm surge rolling in. And we never want to have somebody looking out and saying, I should have listened when they gave me an evacuation order, we should have gotten out, and now it's too late. So tell your parents, pay attention to those warnings, whether you're inland and have to deal with wind and flooding on inland waterways or along the coast with storm surge flooding and wind. These things are dangerous. And the best thing you can do to help us do our job well is to let us all be confident that what we do is making a difference to all of you.
And it certainly does. And the technology for the future, drones are now being used more?
Yeah, we use a bit of drones. There are two types of drones that we've experimented with. One is the Global Hawk, which flies way up there, like 65,000 feet. That's 13 miles above the surface of the ocean. And they're flying back and forth just like when your mom or dad, or if you're a little bit older, you get stuck with mowing the lawn and going back and forth along the lawn. Well, that's kind of like what the Global Hawk does, dropping another version of these. They're a little smaller, but same kind of thing, out, and they fall all the way down, and they get lots of information about the structure of the storm, because they're flying so high they can go right over the top of the storm. And then the other type of drone we're starting to experiment with is a smaller drone. It's not the same like little quadcopter drones you see flying around sometimes in parks or whatever. These are little miniature airplanes that they fire out of the same tubes they release the drop sondes from. Then wings pop out, little propeller pops out, and it can fly along for about an hour or so. And the neat thing about those is that we can send them down really low, close to the surface of the ocean, where it wouldn't be safe for an aircraft with people in to go. And for that, we can get them down there and find out what's going on down really close to the surface, which is very important because, let's face it, that's where we all live. So the forecasters like that they get the information from us up at 10,000 feet, which is where we're typically flying, and then occasionally they get the stuff from these things. But with that small drone, they can get an extended look at what's happening down close to the ocean. And again, that kind of information you can't get any other way.
And can you maybe briefly describe maybe a most memorable or exciting flight you've had?
All right, well, there was one flight I took, and this was back in 2005. That was the year that there were so many storms, we ran out of names. We had to go to the Greek alphabet to name storms. And I was flying Hurricane Rita. And And Rita was a very strong storm, and it was in the middle of the Gulf of Mexico. We went out to fly into it, and it was a nighttime mission. And so we were, coming in for the first time. We were getting to that ring of thunderstorms, that eye wall around the center of the storm where everything's the strongest. And it was a very bumpy ride. You're getting rocked around and slammed against your straps. And there was a lot of lightning flashing out the window. And it was one of those things where you knew it was already kind of a strong storm. And then we broke through the eye wall into the eye. And the first words of the pilot over the intercom were, "Holy," and I won't repeat the rest of it. It was just over the intercom. So, but what that pilot was seeing was most times the eye of a storm, and a big storm, is shaped kind of like a bowl. Like if you're standing at the 50-yard line of a big football stadium and you look around and see all those stands around you, in a hurricane, that's the thunderstorms that are 8-10 miles high. But in Rita, the storm was so strong that the ring of storms around the eye was basically vertical. It was almost like a straight cylinder, a donut, straight all the way down. And the lightning was starting over here, say off the left wing, and just rippling across the front of the aircraft and over to the right wing. And then when you looked up, there was this hole in the sky, the top of the eye, where you could see stars twinkling and a big full moon shining down on us from over the top of all those thunderstorms. And it was just incredibly, incredibly beautiful. And I was just, in that moment, I was thinking, there's so few people on Earth who get to see this kind of power and raw beauty of nature. But at the same time, you always have to respect these storms, because just 2 days after I was on that flight, fortunately, it weakened a bit, but Hurricane Rita slammed into the border area of Texas and Louisiana, and unfortunately caused a lot of destruction and some deaths. So again, Mother Nature can be incredibly beautiful, but you always have to respect the storms, because they can be also incredibly dangerous.
And I think you've perfectly described why do you do it, and for career opportunities for students. I think you just described it's such a cool job to have.
Oh, yeah. Well, I got to admit, I was a weather geek from the time I was 5 years old. And I was going to be a meteorologist. My parents would always say, I'd point up and say, "Look, that's a cumulus cloud." And Mom would go, "Yes, dear," not knowing it. And I was right, but she didn't know. And then I got to 10th grade and the computer bug bit me. This was way back. I'm old. The computers we use, you've got more computer power in your digital watch than the computers that I first started programming on. But computers are incredibly useful. So I did a detour. I was in computers for 10 years, and then the call of the weather got to me. I came back and got a degree in weather. And so, I've been bouncing back and forth between computers and meteorology my whole career. But meteorology is just such a fascinating thing. There's always something going on in the weather. And, there's always something to see and study and learn. And so if you want to get into meteorology, fascinating career, you definitely want to have your good stuff in science and math, because underlying all of the wonders of weather, it's all that complicated math and science about how it all works underneath the hood. And then computers are always a good thing to have, because so much of what we do is involving computers. And then if you do want to go on television, and I speak from experience because I didn't expect it when I got into meteorology, but I got to spend 20 years in television as well. Well, for that, you want to be good at talking to people. So if you get a chance maybe to do your school play, or if any other kind of public speaking experience, a debate club or something like that, those are also good. So you get used to talking in front of an audience and being comfortable just, coming up with things to speak. I'm talking to you now. I have no script. And so to be able to just talk off the cuff about a topic you love, that's always an important skill to have, whether you're going to go on TV or just in regular life as well. So that's another little track you might want to investigate if that is the kind of thing that interests you.
Well, thank you so much for your time and sharing the information and how you're part of this process, as we track hurricanes and the data we get from the aircraft. Very exciting. We can't thank you enough for your time on that. And thank you for your service that you do here at the National Hurricane Center.
Thanks for stopping by today. Take care, kids.
All right.
And thanks, Warren. I was going to show you one other area of the Hurricane Center. We'll just kind of peek in there on the way by. But as we've talked about today, it's a big partnership between the forecasters here at the Hurricane Center, the National Hurricane Center, the media, and others that are trying to make sure we're all ready for the hurricane season. One of those components, and I think I mentioned earlier, They're called emergency managers. We have those in our cities and our counties, and they're the ones that are making sure that our cities and counties and towns are prepared. And so they're the ones that actually have to make the decision on who needs to evacuate, when you need to start putting up those hurricane shutters and start taking all those precautions. So one way we want to make sure they have all the information they need to make those decisions is that we have a group here called the Hurricane Liaison Team. And we actually have a small television studio here where we can talk to these folks at the state and national level. And it's a little small of an area, but if you come through here, you can take a quick peek in here. I don't see anybody in here, so we can go all the way back real quick to show you. We have an area again where we can do what we call briefings. And Weather Service offices, not just here, but the ones around the country, and even the National Hurricane Center, we do what we call decision support briefings. And these are, again, helping these emergency managers, folks in our communities, in our towns, cities, states, and at the national level. You've heard of FEMA, Federal Emergency Management Agency. It's those folks that we're trying to help make sure everyone is safe, everyone is ready, and then when a hurricane hits, they can help get supplies, help us to recover after the storm. And again, they need all that information so they can pre-position all those supplies, all that food, all that water, so after the storm comes, they can be ready to move right in. And so we have an opportunity here to brief all those folks. And we can brief some very high-level folks in this room. I have seen us brief actually the president before in this room, so we can have our Hurricane Center director actually talk right to the president of the United States, again, trying to ensure that we're all staying safe before the hurricane threatens. So I don't know if you have any questions about this area here. They're certainly willing to ask.
Well, it's fascinating. You've really showed us step by step the process, the forecasting process, the reconnaissance data gathering process, but certainly the communication to the emergency management community and the end user, all of us that live not only in South Florida but nationwide, really helping it make it clear. And even at top levels, it's fascinating to know that right in this room, where there can be briefings for the President of the United States.
Yeah, and Warren talked about it so much, but I would encourage any of you as students, no matter what career you're going to decide to do, is to really get comfortable at being a communicator. I wasn't always most comfortable, and I'm not as good as Warren, who spent 20 years on TV, but I do enjoy it. And if you're really passionate about your job, you really have to be able to communicate, to tell folks what you do, and then also if you're in a role where you need to tell people safety messages and what they should be working on or doing, it's really good to be able to communicate. So I really would encourage students out there to take advantage of that. I have an 8th grader and a 4th grader. They're finishing up just like you all here next week from school, but I've encouraged them to try to be good communicators as well, because it'll help you throughout life.
So here we are. Tomorrow's June 1st. We're entering the hurricane season. We know there's been a forecast, but we know regardless of the numbers in the forecast, we need to just always be prepared.
Absolutely. Today we've heard from us as forecasters. We're all prepared for the start of the hurricane season tomorrow. You heard from a Warren who was talking about aircraft. They're all prepared to fly into those storms and gather that data. Really, the next step now is for you all to be prepared. We want everyone safe this hurricane season. So do me one favor, is to go home and ask your parents tonight if you live in a hurricane evacuation zone, and if you do, encourage your parents to find a friend or relative somewhere here in the nearby area you all can go to ride out the storm. You don't have to travel all the way to Orlando when a hurricane threatens. It's just about being safe, and really the phrase is we want folks to run from the water. So if you're in those storm surge areas, that's why we evacuate. If you live in a well-built house, we can kind of hide from that wind. But do things at your house. Make sure you talk to your parents about whether you have shutters for your home and how you can help make sure that you're going to get those shutters up in time. And start thinking about this weekend whether you need to buy some food and water and have those non-perishable foods on hand for this hurricane season. Because I'm going to be doing the same thing. I'll admit I haven't quite got everything stocked up for this hurricane season, but I'll be doing that this weekend as well.
Well, we thank you so much, Dan, for your time today. As we said, we've been live here at the NOAA National Hurricane Center facility, co-located with the National Weather Service Miami office. We talked with Rob Maleta, about the Weather Service. We've talked with you with the National Hurricane Center, all located here on the campus of Florida International University. We just thank you for your partnership with us at FIU and the Extreme Events Institute and the International Hurricane Research Center, our education and outreach programs. It's really truly a team effort of all of us as we prepare for this hurricane season. So we just thank you very much for your time and for your service and the entire team here at the National Hurricane Center for what you all do for us, for the community as well.
I just say thank you for coming in today so we can share it with more people. We love what we do, and we just want everybody to be safe.
All right, Dan. Well, thank you very much again. And everybody listening now, we'll now conclude our broadcast. But everyone have a good weekend and a safe weekend and summer, but a safe hurricane season as well. Bye-bye now.